All right. Well, I'm super excited to be in London again. It's always a wonderful city to visit. And I'm very excited to speak data to you all. So, hi, my name is Polak. I've been working on data for the last 10 plus years. Been doing multiple things, machine learning, building infrastructure for data, Hadoop world, Spark world, Kafka world, all the good old-fashioned data. Except for internals of database, which we're actually going to touch a little bit today, like what does it mean to bring the internals of databases back into a cloud solution, a data lake, and how we can take best practice a little bit. Thumbs up if you can hear me well. Does that feels interesting? Okay, cool. All right, so let's think about our day as data practitioners. Oftentimes, we develop some pipelines that has multiple moving parts in them. We hope for the best, but in reality, often it's a mess. When we push to production, we discover there are some data changes, variety, use cases we didn't expect, some connecting tissues, integrations. Something in my DAG was completely off. AWS users, S3 throw an error, slow rate, right? Happens a lot, especially when multiple people accesses the same data. So while we have great expectations of ourselves and the way we develop data pipelines, in reality, our reality is often a mess. And so we have to wake up in the middle of the night to take care of production issues. We don't really know what happened, and we have to start troubleshooting in real time. So some of the things that can go wrong is EMR clusters, Spark things, Databricks upgrades if you're doing these, schema changes, adding new sources that I need to support right now and expect it to have the same schema at a very high level, but actually in reality I realize because it's JSON, they can actually do whatever they want underneath the hood. Changes in business logic. I'm exposing some data to my customers, and now they're asking me to redo a specific filtering that I did, so I have to go back and fix it. I have infrastructure changes. I have a couple of Spark jobs who ran twice and actually duplicated the data because at the end of the day, something happened and I have to troubleshoot. Late arriving data. Who here worked with late arriving data and had to fix that? I see hands up. So I have to do backfilling of historic data and I want to run my logic again on that data to get good results. Idempotency. Idempotency is a tough one. So non-idempotent pipelines, because there's a lot of moving part, and how can we really make sure we process that exact event once? Exactly once is very hard. And maintaining legacy code. Maintaining means oftentimes I need to replace one of the features, I need to change one of the logic, I need to upgrade some of the systems. So in reality, a lot of things can go wrong, and they are. So some of the practices that we have is around testing. We want to be able to test our data pipeline and create confidence in what it is that we're building. So as engineers, we are doing unit testing, integration testing, system testing, end-to-end testing. And all of these testing requires data. So how do we go about getting that data? We think about what would be a realistic input data to test our systems. So we mock it. Pretty realistic, right? We're going only through the good path of the data that we need, thinking about specific edge cases. We sample production data, hoping that we get the right sample is going to find all the errors or not. At the end, we copy all of production data because we say, okay, I need some copies of real production data, so I'm just going to copy it all, going to create another bucket, an S3 because I can, and copy from one bucket to the other, run my test, and so I'm confident. And I ran the questionnaire around it, asking people, do you really unit test your ETL pipelines? It was really interesting to see that it was a mixed feeling. So some people say, no, why do you need unit testing? Because the biggest pain often is in the end-to-end testing, and they're right, because we want to see how the end-to-end works. Some people said yes. Again, some people believe in the data engineering, software engineering practices. And actually, some data engineer asked, what are unit tests? What do we need them? So let me take you back to the software development lifecycle. How does it look like? Often what we have the build phase. We're writing code, we're writing software. And then we're creating unit tests that runs locally on our machine. So this is the development phase. And then we deployed it to a staging environment. And my staging environment needs to take care of integration, end-to-end, system testing, all of this good stuff. Usually in my staging, I will have automatic testing. Yeah, I can go manually and go start running a couple of things, but I will also have automatic testing over the whole environment. So I can understand how this new piece of code is going to behave in a production-like environment, so I'll create the confidence that I need. And then I'm deploying it into production, but I'm not done because I have to continue measure, validate, log, audit, wake up in the middle of the night of a weekend, and fix issues. So when we think about software development lifecycle, I want to take you into the data lifecycle. And oftentimes when people think about data lifecycle and data management, they only think about the software part. And while it's nice, I want to expose you to a new paradigm, a new idea, where we're actually looking into the lifecycle of our data and how it moves from one stage to the next stage. So if you think at the beginning, we have data sources, we have multiple sources that we stream into our systems. And then we have some data environment. We have the raw data, we're running some transformation, we're bringing it to a stable state, what we call production data, data that is ready to be consumed by our customers. And then we have BI, analytics, machine learning, the data customers inside our organization that are consuming this data or outside of our organization if we're selling this data. So at a high level, we have ingestion, transformation, and then the data customers that does the testing and deployment for us. So what if we can look at it and say, okay, instead of them doing the testing for us and recreating customer churn, because this happens, why if we bring it back and we slow down the process? And in between each one of these transformations, we're actually going to introduce quality gates into it. So we can have the feedback loop that we want to really know what's the stage, what the readiness stage of the data in each and every step of it. So this is what CI/CD for data. It actually runs on my production. It enables me to do continuous integration of my data, and potentially if the data is in a good state, it's a ready state, I can do deployment of the data. If you look at software, we're looking at 3 different pillars: build, test, and deploy. If you're looking at data, and all these 3 different pillars will have different conventions. In order to build a stable data lake, I want to be able to version control my data, all of my data, not only one table, not only structured data. I want to go beyond that. I want to be able to work with unstructured and semi-structured. I want to be able to work with JSON. I want to be able to work with all the data that comes into my system. So I want to have data version control on top of all my data lake. So this is the first part when we're doing the build. Second part is the CI, the testing. I want to create isolated data environment that enables me to test everything that I do in a way that doesn't harm my production data down the line. And I want to have it on demand. I want to be able to zero copy all my production data, measure and run my pipelines, and test them. And I want to be able to automate all these tests, because if I'll do it manually, I won't have production, I won't have a business. So I want to be able to automate all these tests in order to gain confidence in the readiness state of my data. And next phase is CD, the deployment of my data. So assuming I have my isolated data environment runs inside my production, I'm happy with the result. I automated all my tests. My test gives me green light. Hopefully my tests are good. Quality check passed. I want to deploy. Well, this is nice. I want to also be able, if I did do a mistake in my test, if that something accidentally happened, and that happens to us in software, I want to be able to roll back to a stable version. I want to be able to say, okay, I accidentally promote what I think was a healthy data to my consumers. They somehow realized that, or I captured that on time. So I want to be able to roll back from that CD into a stable state of the data. So this is a very high level of relatively new paradigm of data lifecycle management and CI/CD best practices. And you're probably asking yourself, what is happening today and why do we need it, right? So today we don't guarantee data quality in our production system often. If we are very, very brilliant engineers, we would couple it with our Spark jobs. It will be part of my jar, part of my Python logic, maybe some SQL under the hood. I hope someone is making sure the quality is good. So when data gets corrupted, it's really hard to find what happened. It's really hard to find the exact snapshot, the exact version of what's got wrong. So we want to be able to test it, but we want to be able to troubleshoot it. And it makes it very, very hard with today's data lakes. And so, like I mentioned before, we want to build version control. So let's assume we have all our data sitting in S3, Azure ADLS, GCP file system, and I'm looking at it horizontally. So I'm having all my tables in one bucket, for example. And in this bucket, I can have my main, or I can have two buckets, my main bucket and V1, my version bucket. And the version bucket is going to be a snapshot, a zero copy of my data. So that will be the first phase for me. So I'm data versioning at the object level. I'm looking at the binary format of the data. So I'm not attached to a specific table format. And I can branch out, so I can copy, and a similar thing to it is branching, so I can branch out over the whole repository. And this is lakeFS, basically the project, open source project that I'm contributing to. It provides us the capabilities to run Git for data. So it looks over metadata of what happens, and it enables us the view of having multiple branches on top of my production data. And it does it with zero copy mechanism. So if I have my URI at the top, the S3, I have some data repo, all I need to do is add another /main/my collection into it and link my lakeFS server to look at it to know what happened. And so when I want to do zero copy of my production data in order to test it, in order to build that CI/CD mechanism, in order to add data quality gates into my production, I am able to do it because I have this mechanism. I have the different folder organized there, or repository, or branches, however you want to call it, built in already. And the nicest things about it, it sits as a sidecar to your data lake. So if you have all types of object stores in there, you have lakeFS on the side, and you can do all the compute you want, and the compute is going to connect directly to your data lake, and it's going to send metadata to lakeFS to enable you the Git-like capabilities. You're probably curious how it does it, why zero copy, very much engineering heavy here. So the way it does it, it only hash the file itself, so it looks at object by object, and it tells you if the object got changed, if the file itself got changed. It doesn't care about the schema. It runs on binary. It doesn't care about the columns. It doesn't care about what's in it. It only knows that something got changed, and it can tell you how many bytes got changed inside that data. And it also audits it for you, so it can tell you so-and-so file got changed in so-and-so branch by so-and-so at so-and-so time. So if you need to be able to know what happened with your data, where all your copies are stored, who used them, who touched them, who copied them, it's really a great mechanism to audit what happens in your storage. So the last thing it does, it's copy on write. And copy on write comes from the world of databases. So you have a copy in memory, zero copy. You run some compute on it, and only after when you want to write it back into disk, this is when lakeFS is going to copy your data. And statistically, oftentimes, what we write back to storage is often only 20% of the data we actually consumed. Because when you think about data pipeline, we have all this life cycle that comes from sources, we're ingesting it into the system, we're filtering, we're doing some enrichment, we're adding more rows, we're removing some rows, we're looking at specific timestamp. And at the end of the day, what happens, what really got changed into our data, so it's only 20%. So it's a brilliant mechanism that enables you to do that right out of the box. So this is the build part. So what about the CI? So in CI, we want to be able to create safe space for us to actually test the data. So isolated data environment on demand. And we can do it using the client, or we can do it using the CLI if we wish to. So we are branching out of our production and creating an ingestion branch and ingesting any data we want. It can be dirty data, it can be good data, it can be something that where the schema changes, my JSON changed, anything that I want. And then I'm doing commit. And commit is going to commit that specific change into my ingestion branch. If I'm happy with the result, I can merge it back into my protected main branch that later on is being exposed to my customers. So this is one if I want to do ingestion. What if I just want to develop some code and I want to do experimentation? So that I can do as well. And that I can do by having multiple commits on the same branch where I'm experimenting and changing it, so I can actually revert and roll back for each and every of that commit. So you can compare it to any Spark job that you run when you're doing some compute, and then you're saving to storage, and then you're running some more compute, and then you're saving to storage, in order for you not to do all that compute over and over again. So after a couple of commits, a couple of actions that I'm doing, I can merge it back into my mainstream, and on each one of them, I'm able to roll back to that specific commit. So we can take these both approaches and actually automate it. So we can automate it in a way where I have my dirty ingestion branch, and I am now injecting some bad data, but I can have a mechanism at the end that detects it actually was a bad data and revert. Or I can have a mechanism at the end that detects it was a bad data and wake me up in the middle of the night so I can revert, but at least it's one click, but then I have some more time to troubleshoot it without the panic of, customers at the end. So it's a great mechanism to help us automate this process. And the CD part, because we want to be able to deploy it all the time, constantly, and then is where the hooks comes in. So if you work with GitHub has actions. Anyone work with GitHub Actions to automate their CI/CD and software? Perfect. So we can actually automate it with lakeFS hooks. That is there's a web server, basically webhooks there. Where you can define what are the tasks that you want to do, and you give it the actions that you want it to make on behalf of you when looking at the different branches that it has. So similar to GitHub webhook, GitHub Actions, you can have a pre-commit there, and you can have similar experience with lakeFS with the pre-merged hooks. And here I'm going to show you just an example where the hooks can run as a Python web server on Flask, or it can be any other server that you want to have. And you can trigger that performance test on the action that you defined it. So you can add your custom test, you can use tests that it has out of the box, you can connect it with great expectations, so that gives you the infrastructure that you need to enable more work and more best practices down the line. And how do we do it? So actions itself, at the end of the day, is a YAML file. So I can define my YAML file and then put it inside my branch, so it gives me all these capabilities. So it has a name, and here I just decide to be Parquet only in production. And this example is going to make sure I'm only promoting Parquet files to my production users, so something that happens. I'm giving it some descriptions of what it does, because I want to be nice to my colleagues. I want them to know what these things do. I'm giving on, so on when does it start to work. So this specifically start to work on pre-merge, and pre-merge to a specific branch. So pre-merge into my main branch. I'm defining the hooks itself, what it's going to be. I'm giving it an ID. And the most important, I'm giving it properties. I want to know which webhook server to connect to and what is it going to check for me. So here I have my query params, where I allow only Parquet and Delta Lake formats, and I can deploy to production. So I have my lakeFS hooks that supports multiple events with pre-commit, post-commit, pre-merge, everything that you can think about that available around branches, pre-deleted branches, created tags if you want to connect some branches with some specific code that you changed, post operations as well. And that enables me to do that automatically, and that enables me to roll back in place as well. So I can have my post-merge, for example, or revert to a specific version. All right, I'd love to see a demo. I hope you're excited. Okay, so I created a local demo because Wi-Fi. Very, very high level, lakeFS looks like GitHub. And I created also a repository that's available for you. This repository is actually empty. So if I'm looking into it, you can see storage namespace is linked into S3. But S3, for me, under the hood, is actually a MinIO console because I have to run it locally because Wi-Fi. When I look into it, I can go through the branches. So you can see this one is actually empty. I can look into the branches. I have no branches at this moment. So let's go into my Jupyter Hub. In my Jupyter Hub, I'm configuring a bunch of things. I'm making Spark nodes that lakeFS exists. I'm giving it the URI. And I'm creating a client for lakeFS. So I have a lakeFS client. This is a Python client. I'm defining the repos that I want to work with. I'm defining the ingest branch, staging branch name, production branch. I'm doing a list of all my branches. You can see now I don't have any branches. I have only main. And I'm doing create branch. So I'm creating my new branches that I want, ingest and prod. Ingested is a copy of prod. And I'm creating a staging branch here as well. So now when I'm doing listing all my branches, I already have a couple of more branches. I have ingest landing area, I have my main, and I have my staging area. So you can already see how that all connects to my CI, because I have my ingesting landing zone with all my sources coming into the system, my staging area where I'm doing some processes on top of that data, and then production, what is being exposed, what I'm happy with. So I'm taking some data into the system. I'm copying. I'm opening some of the data and I'm uploading some objects. And I can do diff on top of this. So I know I uploaded some movies, CSV, and that's all with lakeFS. Well, this is nice. I want to be able to do it with Spark as well, right? So first of all, before starting, I want to make sure my action YAML is in place. So if you're looking here on my Jupyter, what I have is the notebook for the demo, actions, and the data. So I need to make sure my actions file sits within the branch. So I want to have these guarantees built in. So I have my hooks config YAML, the name of the file, the hooks prefix, what lakeFS looks for, so where it looks for its own actions. And then I'm uploading this object. So this is a very much data ops operation to prepare the branches before I am actually doing anything on them. Doing diff, I know something got changed, size in bytes. And I'm doing commit, because I want to make sure I'm committing it. So I'm extracting some data from ingest branch. And this is all graded nice. Printing, doing some Spark operation. Here you go. So you can see all the great movies from Netflix. Loading more data into my staging area. So here you can see I'm using Spark API. So here when I'm writing more data that I need, not only on one action file, I'm actually leveraging this. All right, and I know one of my actions here, if I'll go back to my actions YAML, and this is what we see before, it allows only Parquet and Delta Lake. So these are the only files that I'm allowing to push back into my main. Here I have a CSV file. Okay? So let's see what happens when I'm doing it. My commit works. That's great. But what will happen when I actually want to merge back? On merge, I'm getting this exceptions. And this exception is going to make sure I'm adhering to my own data quality gates inside my branches. So here it tells me hooks run ID, failed on action, Parquet only in production, hook format, paused, unsupported protocol, schema. So that enables me, this is an infrastructure that enables me to really build that in and bake that in when we work together as a team on my production data. And if I go back to my lakeFS UI, I can go into action and actually see all the merges, all the actions that I did, what happened, why it failed, look at the statuses, status event, look into the error, and really start to troubleshoot if it shouldn't happen, or give me more insight of what truly happens in my data, in my production, when I'm looking at my data pipelines from a data lifecycle management perspective, where I'm actually being cautious of everything that happens and what is the data readiness at the end of the day. And just to show you, my main branch is still empty because I wasn't able to merge my data. However, now I have two new branches. One is the adjusting landing area and one is the staging area that does have more information. And only after I'm fixing it from CSV format to a Parquet format, that this is what allowed downstream, I will be able to merge it back. All right. This is about it. We have about 2 minutes. lakeFS is an open source project, so if you want to contribute, would love to see you there, and I'm more than happy to take questions. If people want to ask questions, you can come along. More than happy to support you. Know the orchestration here is interesting. Thank you so much.